Hello students, welcome. Previously Form 4, Topic 2, Lesson 8, we were doing Hess's Law. I've done question 1. So today, Lesson 9, I'm going to do question 2 of Hess's Law. And the question reads like this. We are told use the standard enthalpies of combustion below to calculate the enthalpy of formation of borobane. So we are supposed to get the enthalpy of formation of borobane. Okay, how do you write borobane? Borobane is written C3, then H8. That's how we are going to write borobane. So, what is enthalpy of formation? Enthalpy of formation, we said, is the enthalpy change when 1 mole of a substance is formed from its constituent elements in their standard state. So, what are the constituent elements of borobane? It is carbon, which is solid, plus hydrogen, which is gas, giving us now borobane. Okay, learners, we are going to do energy circle first of all, then we are going to use that energy circle to calculate the enthalpy of formation of borobane. So let's balance this equation. We are going to put 3 on that side of carbon and 4 on that side of hydrogen to balance the equation. Okay, next, let's check. We are having here these equations, the thermochemical equations given. We are having borobane burn in oxygen giving us carbon dioxide and water. And that equation is here, borobane is here. If we get an arrow, that means we add 5 moles of oxygen gas. We are going to get 3 moles of carbon dioxide as our product, plus 4 moles of water, which is liquid. Okay, that is what we are going to get. So next here, the thermochemical equation given, we have carbon reacting with oxygen giving us carbon dioxide. And that equation, we can get it here, carbon, then we are going to have an arrow, then plus oxygen gas, we are going to get carbon dioxide. But let us balance that equation because we have 3 carbon here and we have 3 carbon here. So we have 6 oxygen, so we are supposed to put 3 there, so we have 3 mole of oxygen gas. Next, we are having hydrogen gas reacting with half of oxygen gas giving us water. So we are going to have that hydrogen reacting with oxygen gas. So let's balance again that equation. Here we are having 8 hydrogen, even here we have 8 hydrogen. That means we have 4 of oxygen. We are supposed to put 2 here, so we also have 4 oxygen on that other side. Okay, next we are going to relate now, because we said if we use Hess's law states that the energy change in converting reactants to products is the same. That's what it states. Despite, or we say the energy change in converting reactants to reactants and products is the same regardless of the route by which the chemical change occurs. So in our case, there are 2 routes of obtaining carbon dioxide and water. One route is this route. That's carbon burning in oxygen giving us carbon dioxide, plus hydrogen burning in oxygen giving us water. That's one route. So the other route is carbon reacting with hydrogen giving us borobane, and we take that borobane, we burn in oxygen, we are going to get carbon dioxide and also water. So let's just try to have some enthalpy change 1 and enthalpy change 2, then this is enthalpy change 3, and we have here enthalpy change 4. So the expression will be enthalpy change 1, it is going to become enthalpy change 1 plus enthalpy change 2 will be equal to you having enthalpy change 3 plus enthalpy change 4. Okay, from here, let's just try to look the enthalpy of combustion of carbon to produce carbon dioxide. Here we have negative 393. But check, initially, what we have here is the standard enthalpy of formation of carbon dioxide, which is 1 mole of carbon dioxide formed, it is constituent elements. So that means if you check the energy circle, we have 3, 3, and 3. That means we are going to multiply our heat, the standard enthalpy of combustion of carbon, by 3. Okay, here enthalpy change 1 will be 3 in bracket negative 393 kilojoules per mole plus. We go on the side of hydrogen. So here we have hydrogen reacting with half mole of oxygen gas giving us 1 mole of water. So what we have negative 286, it is the standard enthalpy of combustion of hydrogen. So, but if you check the energy cycle, we are having 4, or we have multiplied the whole of this equation by 4. So that means we are supposed to also multiply this standard enthalpy of combustion of hydrogen by 4 also. So we are going to have 4 in bracket negative 286 kilojoules per mole. This will be equal to enthalpy 23, which I don't know. That's the one I'm looking for, plus that side of combustion of propane. And the combustion of propane here, we are going to have negative 2209. So we are going to have minus 2209 kilojoules per mole. Okay, if we put all this in the calculator, we are going to get negative 2323. So will be equal to enthalpy 23 minus 2209. So if we want enthalpy 23, so that means we are supposed to say negative 2323, then this one will go on the other side and becomes positive 2209. That means enthalpy 23 will be equal to negative 114 kilojoules per mole. So this negative 114 kilojoules per mole will be the enthalpy of the formation of propane, which we have here, enthalpy 23. So that's the end of our lesson.